Hi, in this tutorial I'd like to talk about the domestic hot water, and you can see what I've listed up here is the different tables that we have to fill out when we're talking about this. If we go to the program, here you can see I have clicked on hot water, domestic hot water, and first you have to give it a description, a good name, and that can be domestic hot water. Then we have to fill out how much we are using a year, and normally for dwelling it is 250. That we can read in the SBI, and you can also see it in the guideline. I have listed it up here, where you can see it in the SBI, and for dwelling it's often 250. Then there is a temperature, what temperature the hot water should have, and it's 55, and 55 is the reason for that it has to get to this temperature, so we are sure that Legionella bacteria are killed, and not warmer, because if we have warmer, then we will have a risk of burning ourselves when we turn on the hot water. So that's the reason. Then the next table we have to go into is the domestic hot water exchanger or tank, and you don't have that table. To get it active, you need to right click on over here and then add the hot water tank. Then you get this table up here, and you have to again to give it a name, and you give it hot water exchanger or tank according to what you have. When you have an exchanger, then you don't have any volume for the hot water to stay, because there isn't any volume for the exchanger. If you have a tank, then you put the volume here. So if it's, for example, it's a 500 liter, then you put 500 liter there. Then you have the number of exchangers or tanks you put in here, and then over here you write one if all the hot water is made by this exchanger, and normally it is. Then we have the supply temperature, and it's coming from the district heating, so it's 70. Then if we have an electrical heater on the hot water exchanger or boiler, then because we have district heating, we never have an electrical heating on it, so therefore it's no. Then we have this heat loss in the exchanger, and that is normally 1. And then this one here, that's a B factor, and the B factor is 0 if it's inside the heated zone. Then there's the charging pumps, and if we could have charging pumps, but normally there isn't in dwelling, so therefore it's 0. All this information you can also read about it in the SBI or in the guideline. Then we move on to the next table down here, and the next table is about the connection pipe, and the connection pipe is from the district heating coming into the house up to the hot water exchanger, and I've made a small drawing so you can see it, and here it is. Here you can see what we have is that we have the cold water coming from outside, and then we have the hot water exchanger here, so we get hot water afterwards. Then we also have the heat coming and going in here to the heat system, and that from the main pipe coming in up to the hot water exchanger, this distance here, and also returning, that's the connection pipe, and that would normally be 2 meters, because we have it in the scullery where we have a cupboard where we have the exchanger, so it's done inside there. Then we have the next part about domestic hot water, and that's the circulation pump. If we have a circulation pump, then we put it here. Then we write 1 here, and normally the effect this using is 20. And then we have a reduction factor, and we have to put 1 here because it's always running. We also have to put in the circulation pipe here, and that's the length of the circulation pipe, and that's the whole circle, and I made a drawing so you can see it. So what we have is that if we have the hot water exchanger here, and we have to the farthest away place where we have hot water, that pipe there, and then we have it coming back on a circulation pipe. So that means that we will always have hot water running here. If it takes, we need this pipe if it takes more than 10 seconds for the hot water to get up here. You should try not to have this circulation pipe, because it uses a lot of energy, and it would be good for the house that we don't have it, because then we use less energy. But if you have it, then you write circulation pump here, you write the length going up and back here, and then you have the heat loss here, which is 0.2, and then it's inside the building, then it's 0 here. You can also see these information in the guideline. If I just go to the guideline and I go down, then you can see we have the information about the circulation pump and about the pipe here. Now try and make the assignment for this. Use also these fixed numbers in your own project. And have a nice time.